Hola mis estudiantes y bienvenidos to the lesson on 4.1. Hello CTM students. I purposely began there in a different language, and I think you'll see why as this lesson goes on. I'll just leave it at that for now, other than we're going to learn a lot about different cultures with this lesson for sure. So here is some new vocabulary here. You may be like, well, I know what a number is and I know what a numeral is. Let's see if you really do. See if you really understand it. And then all these other terms, make sure you understand those by the end of this lesson. And as always, make sure you're using the book for extra examples. I am doing some different ones than what are in the book, but similar to what you see here is what's in the book. Okay, so let's start off by defining some things. What is a number? Well, you might say a number is like a digit, or you might say a number is whatever. I'm not exactly sure. A number, though, for us, what it really is at its core, its essence, is it's just a quantity. A numeral is probably more what you're thinking of. So a number is a quantity, but a numeral, that's a symbol. So this is a symbol. And it could be like, well, we're going to learn one different type of system that uses this as a certain value. Another one that uses this, kind of like a darkened one here, as a different value. And for us, 10 represents the same value that a certain culture this represented 10, and another culture this represented 10. So it's just a symbol like this that represents a number. So a symbol that represents a number. And a system of numeration is this. It consists of a set of numerals and a scheme or rule for combining the numerals to represent numbers. And then the Hindu-Arabic system, you might be thinking, well, that sounds really, really complex. I don't know if I could ever learn the Hindu-Arabic system. I think you already know it, actually. So it's the numeral system that we use, the numeral system we use. So our system has the digits 0 through 9, and it's also a place value system. We'll learn more about that, what a place value system is, in the next section, in the next lesson. Place value system. So this is a system that we use. So hopefully you've already written this at the top of your page for your title, but we're going to learn about additive systems, multiplicative systems, and ciphered systems of numeration in this lesson. We'll learn about place value systems in the next section. So moving on to the next slide here, some additive systems. Just make this kind of a big topic heading for you in your notes. Not as big as this necessarily at the top, but this will be one of our big topic headings, additive systems. So we're going to start off with the Egyptian system. So the Egyptians, they had their own system. Ancient Egyptians had their own system of numeration. They had these numerals. So do I expect you to memorize all these different cultures and what they use for numerals? No, not unless I tell you specifically. So the Egyptian numerals, I'm not expecting you to memorize that this is a 1 and this is 10 and this is 100 and this lotus flower is 1,000 and the pointing finger tadpole and astonished person. I love that. An astonished person. An astonished person represents 1 million. I think 1 million is pretty astonishing, yes, as a number. But the Egyptian system, Well, let's write down a couple of things about this first. So I do want you to write this down at least, and then we'll have this table either to refer to in our books, or I'll give you a copy of something. If I expect you to use it on a quiz or a test, something like that, I would give you the copy of this at your disposal to help you figure out what's what. So each symbol in the Egyptian system, each symbol represents a specific quantity. So each symbol here is a specific quantity. We can see that down here. And what we do when we're using the Egyptian system is we just add them all together. We'll generally put them in order as well, from kind of biggest to smallest, but in this system, this is actually true, that order doesn't matter. Order doesn't even matter. You could put the 1 first, the symbol for 1 first, and you could put a symbol for this next, then you could put an astonished person, a million next, and you could put a bunch of these next. So the order doesn't even matter in this Egyptian system. This is an additive system, so we're basically just adding all the symbols together and seeing what it equals. So let's start off with this example. So you're going to see me struggle through this a little bit, and you're going to do the same thing here too. So an astonished person, that represents a million. I'm going to write these as best as I can. I just want you to do the same. As long as it looks halfway like what it's looking there in your book. This is kind of small here. You can look in your book on table, I think it was table 4.1 in lesson 1, yeah, 4.1. And you can see these a little bit clearer, I think, there. But you got the astonished person. I'm going to draw 3 pointing fingers as best I can. 3 pointing fingers. And then this rolled up scroll, what they called that there, I believe. Yeah, the scroll or the coiled rope is what they said there. And then this heel bone arch. It's not quite the same as our union symbol or intersection symbol, I should say. It's not quite like that, so it's a little bit different. You can see a slight variation there, but it's basically the same thing essentially. It's an upside down U pretty much. And then I'm going to draw 1, 2, 3, 4, 5, 6 tally marks right there. So we're going to try to write this Egyptian symbol. This looks like Egyptian hieroglyphics to me, Mr. Wagner. Yeah, it is. It is Egyptian hieroglyphics. Look, right there. It says Egyptian hieroglyphics. So that's exactly what we're doing. We're learning some Egyptian hieroglyphics here. So this, what does this equal? Okay, so I'm going to use some yellow here to kind of connect things as I go along. You might want to use a lighter color, real lightly in pencil, connecting some things as you go along. So I see a million right here, and I see another million right here. That would make 2 million. You could say a million plus a million, but I think I'm good just writing 2 million. I see 2 millions right there. So I'm going to connect this right here. I'm going to say that matched up with that right there. Okay? And I think I'll use orange for my next one, kind of delineate between the things as I go. How many pointing fingers do I see? I see 3 of those. And each one of those pointing fingers counts as 10,000. So if I have 3 10,000s, I have 30,000 if I put those 3 things together. So this now, and this, that's where that came from, that 30,000. This, connect right there to that. And now what else do I got? I've got, well, this thing, this scroll is supposed to be 100. So I'm going to have this. It's going to be plus 100 more. The heel bone arches, the heel bone or arch, what we have there, I've got 2 of those, and each one of those is supposed to be 10. So 10 plus 10, that would be 20 more. And then the tally marks, they're just 1 each. So I see 6 tally marks. I'm going to have plus 6 for that right there. So I will connect all these things here. Oops, I meant to do this first here. So this was a 100. This was the 20. That's where that came from. and then finally the 6 came from the 6 tally marks right here. So all these things connecting together like this. Do you have to in your later homework or problems you're working on, do you have to connect all these? No, but do that for now just so you remember where that all came from. So now it's just a matter of hopefully simple addition here. This will be 2 million. There's no 100,000 there, so that will be a 0. 2,030,000, no thousands place either. Sounds like Caesar. 126. So if I work this all out, that is the number I get. So 2,030,126 in Egyptian hieroglyphics looks like this. Let's do another example with Egyptian hieroglyphics. So using the Egyptian system of numeration. Now let me give you the Hindu Arabic number. Let me give you that to start. So let's say I said I wanted you to put this 31,182. I wanted you to write that in Egyptian hieroglyphics. What would that look like? Well, I've got 30,000. So to each 10,000 is the pointing finger. So I've got 3 pointing fingers like that. Okay, and that will be connected here. So I'll say this and this all matched up. And now I've got that for 30,000. The 1,000 is this lotus flower. So that's pretty hard to see what it quite looks like there. But if you look a little closer at your book, you have something that looks like this, and then a little arrow like this, and then kind of a something that looks something like that. So that is the lotus flower as best as I can draw it here with this program that I'm using. So this one, there's only one of those, so that came right there. Alright, so let's see what else we got. We got another one that's in the hundreds place. So this 100, that's the Egyptian numeral like that. So I would have the scroll symbol there. This one would match up with this right here. And again, these circles, what I'm circling here, that's not going to be in your other problems here, but let's just do that here so that we know what matches up with what, where this number came from. Now I've got 8 in the tens place, so we have 10 of these things to draw. I picked an easier one for this to draw 8 of these things. So 8 arches, 5, 6, 7, and 8. Okay, so all that, got to draw that 8 times just to represent that number 8. Perhaps you're starting to see one of the disadvantages to this system. And then finally 2. So we've got all that now taken care of. The 2, that's that here. And then this, if I removed all the colored parts there, that would be, if I just wrote that all together in one string, that would be my final answer. And remember, the order actually doesn't matter with Egyptian hieroglyphics. So this could come before this stuff could come over here. I can mix the order of all these around, but I think it's just easiest, and I want you to on your homework, on your tests and stuff, just so it's easier to look at, to write them in order, to write them so that they get smaller and smaller as we go. So before we move on to this next system, let's talk a little bit more about the Egyptian system. So there was no symbol for 0 actually. You don't even see a symbol for 0 down here. There wasn't one. So that definitely brought about some problems. How do you represent 0 in a system with no 0? Well, it was kind of difficult to communicate that with other people. They did have a thing for fractions that they used. You can read about that in the book if you'd like to. And another thing you may have seen here, okay, this is a pretty long way to write, just for what us in Hindu Arabic system, it only takes 5 symbols basically to write. We got 3, 4, 5, and 8 more, 13, 15 different symbols to write. If you wrote the number, don't write this down right now, but if you tried to write 9,999,999 with Egyptian hieroglyphics, it would actually take 63 symbols. It would take 63 symbols. Basically, that's just 9 times 7 here. There's 7 different 9s, so you'd have to write this 9 times. You'd have to write this 9 times, and this 9 times. and this, and this, and this. All these symbols you have to write down 9 different times just to represent that number, 63. So while I'm done writing the number and I ate my lunch already, this other guy is still writing down the number for 9,999,999 in Egyptian hieroglyphics. So there were some disadvantages to this system for sure. The Romans, they came around and they came up with their own system of numeration, and it had some advantages over the Egyptian system. So let's write down a couple of those advantages here. One of those advantages was that it used something called the subtraction principle. So it used subtraction principle as well as the addition principle. So we saw the addition principle with the Egyptian hieroglyphics, but that's the only thing it could do. They could only add all the things together the way they were using it. So you may have seen Roman numerals before. I hope you have at some point. But if you haven't, or you're just really unfamiliar, you just forgot things, how it dealt, or how you dealt with Roman numerals. Basically, it's like this. You're starting from the left. You start from the left, and then from there, you're going to add each numeral unless its value is smaller than the value of the numeral to its right. And in that case, you're going to subtract. So you would subtract when this happens. And then a second thing that was advantageous over the Egyptian system with the Roman system is that they made use, it makes use of the multiplication principle as well. It makes use of the multiplication principle as well for numbers over 1,000. For numbers over 1,000. And for right now, we're not going to get too worried about this. We're going to definitely be using the advantage number 1, but advantage number 2, this one might do some problems in class dealing with this. You actually use bars over the letters for the multiplication principle. That's how you would designate that. But let's just worry about, for right now in the notes for this lecture here, just worry about advantage number 1. Roman numerals, what are they? I bet you've seen them before. So you got an I. An I in Hindu Arabic is just 1. You also have the V. A V in Hindu Arabic is 5. That represents the number 5 for us. A or an X represents 10. I hope you remember those 3. These other ones might not be as familiar to you though. The C, I want to do the L first though, sorry. L represents 50. The C represents 100. And an M represents 1,000. Represents 1,000. So how can you keep these straight? These are ones that I do expect you to get memorized. This M for 1,000, I think of millennium. So a millennium is 1,000 years. M matches up with 1,000. For C, I think of a century. Century is 100 years, so C matches up with 100. These 3 you should know from before. Excuse me. Dealing with clocks, sometimes they have Roman numerals, and then the L. I'm not thinking of a clever way to remember L is 50, but maybe you can come up with something and tell me in class what you come up with, and we could use that as a way, a mnemonic device to remember what L is. But century, 100, millennium, 1,000. I think that's going to help a lot there. So let's write down, or let's work on another example here. So some some stuff here. I forgot to point some of this stuff out. This was actually the Roman Empire at its height. That's just like it says here. The Roman Empire was very expansive, basically surrounding the entire Mediterranean Sea. You got the Colosseum here, and you got what a lot of people think of, a guy that looks like this when they think of an ancient Roman guy. But here is one of the ancient Roman roads. Example 3, let's try to write this number as a Hindu Arabic numeral. MMCLXXIII. Okay, so let's break it down like we did with the Egyptian numerals, and let's just start with here, these two M's. What are those two M's going to be? Well, that's going to be, if you look back here, I actually want to copy and paste this a second to my other slides here so I can use that. Alright, and like magic, there it is. So we got all that stuff. What's the M represent? Well, remember that's kind of like millennium, so that's 1,000. So I've got two of those. That's going to be 2,000. So this, I'm going to break it apart into its steps here. 2,000 for that. So this connects with this up here. What's the C? Well, the C is 100. So we have plus 100. So that connects with that right there, plus 100. What's the L represent? The L represents 50. So we have this. We have plus 50. That's going to get connected here and here. And again, this kind of stuff, not something we have to do later. It's just something I want you to do right now so you remember where each one of these numbers came from. So now I've got two X's. Those two X's are going to be, we got X is 10, so I've got two of those. I'm going to have plus 20. And then I'll connect that here. And then my last one there, I've got three different tally marks. That's like this. You can write the I without the little horizontal part there and there too. You're going to see it that way in a lot of textbooks in your book. So know that either this or something like this, or it's meaning the same thing. So the little tally marks there, that is plus 3 more. We have plus 3. So we put this all together, and let's see what we got. We got 2,000 plus 100 plus 50. It's 2150 plus 20 more is going to be 2170 plus 3 more is going to be 2173. So this one, 2,173 would be your answer for something like that. For this next one, I want to play a little video here for you first. Alright, so let's see if you recognize this music here. And oh, there it is! That's what I'm looking for. This MCMXCIV. Alright, so why do I bring that up? What's the purpose behind that? Alright, so like magic, we're back to this screen. And let me write down that number I saw there again. So this was MCMXCIV. So what is all that? What does that mean? Remember, we have this rule where, using the subtraction principle, if you start from the left, add each numeral unless its value is smaller than the value of the numeral to its right. And we subtract when that happens. So here, that never happened. All these values to the left were always bigger than the values to the right. But here it happens. I see this C, which is less than the value of M. So I'm supposed to subtract when that happens. I'm supposed to subtract 100 from 1,000 to get that. Excuse me. So when I do that here, let's start off with this M. So I'm going to say that this M, that's what I'm going to start off with here. There we go. This is going to equal 1,000. And now this together. The C is less than the M, so I subtract that from that. I subtract 100 from 1,000. And when I do that, I'm going to write it out for right now like that. I'm going to write plus 1,000 minus 100. So that would be a step you could skip later on if you get good enough at this. But for right now, let's write it down like that. So it's subtraction principle into play right there. 100 minus 1,000. Let's see what else we got. Well, I've got X before a C. An x is 10, a c is 100. So this one, again, I have a number that's less than the number before it. This, I have to use that subtraction principle again. So this is supposed to be, I'll have plus, this is going to be 100 minus 10. So that matches up with that. And then finally it happens one more time. You've got an I before a V. The I is 1, the V is 5. So this becomes, we have plus 5 minus 1 right there at the end. So this matches up with that. Now we can simplify this. We got 100, or we got 1,000, sorry, plus 900 plus 90 plus 4. Add all that together and you get 1,994. Or, for the purposes of what we were talking about here, those were the credits to this incredible movie, one of my all-time favorites. Hey, it's Forrest Gump. So this was the year Forrest Gump was released. That's why they had that number in Roman numerals at the end. If you ever watch movie credits carefully, you'll always notice Roman numerals at the end. They don't put the year in normal numerals. In our Hindu Arabic system, they use Roman numerals to do that. Why that is, I'm not exactly sure, but I think it's pretty cool that that's there. So some of my favorite scenes from Forrest Gump. Loved when he ran across the country. I'm definitely big into long distance hiking and things like that. Play some ping pong with my Flexo Light ping pong battle. Me and Jenny was like, come on, peas and carrots. Alright, anyway, moving on. Example 5, and some more. Now we're going to go backwards. We're going to work backwards. We're going to start with the Hindu Arabic number. So 1256. Let's start with that. What does that equal as a Roman numeral? So this, let's work this out. The 1, that's 1,000, so I can represent that with an M. Here's an M. That's all I need for that. So this connects here with that. The 2, 200. In the 200s place, I just need 2 C's for that. So I'm going to write M, C, C. And so this connected with that there. And then I've got 5 in the tens place. So I've got 5 of these, but I don't want to use 5 of these. I want to use the L for that. So that's why we have the L. In case there's a 50 or a 60, we can use an L or an LX. Here we just have a 50, so I just use an L right here. And then the 6, how can I represent the 6? Well, that I'm going to use, I don't have a number or a numeral for 6, but I do have a numeral for 5, and then I add 1 to that. So 5 plus 1, write the 1 to the right of the 5, and that will give me what I need there. So this 6 is represented by this VI right there. So this would be it. This would be everything I need to do for that. There was no need to use the subtraction principle in that one. Let's do one though where you do need to utilize that subtraction principle. Did I have a picture there? I did have a picture there. What was that signifying? Woo! Oh yes. Okay, so this used to be the world's largest commercially available hamburger. I have this 2008 Guinness Book of World Records. It's a few years old, but it was available apparently for $23.95 in a place in Thailand. And if you could eat it all within 3 hours, they would give it to you for free. But that thing weighed, I think it was 78 pounds, 8 ounces. 78 pounds times 16 ounces in a pound. That gives you, if you add 8 more ounces to that, that gives you 1,256. So this was a 1,256 ounce burger. Pretty crazy that they offered something like that. I don't know if they still do that. I don't know how they can make that for $23.95. That's just nuts. But anyways, moving on to a final Roman numeral example. So this is example 6 here. We're going to write 379 as a Roman numeral right here. So 379, what would that look like in Roman numerals? So I've got 300s, so that I could represent pretty easily with that. Just put a C, C, C. Hey, that's like the Civilian Conservation Corps back in Franklin Delano Roosevelt's day. Part of the New Deal project right there. Pretty cool. Gave a lot of people jobs, the CCC, back in those times, battling the Depression years right there. So 379. Why did I circle the whole thing? I think I was distracted there by talking about the CCC, so let me erase some of that. I only meant to circle the 3 there, so let's connect that appropriately. That's why we'll use pencil when we do this. Oops. And yellow, there we go. Okay, so 3 represents that. That's a 9. That didn't, I think they got erased or something, or maybe I just didn't write it all the way there. So 79, how do I represent 79? Well, 70, I can do that without too much trouble. That's going to be a 50, and then 2 10s after that. So I'll have an L, and then 2 10s, an X, and an X. So this 70 matches up with this part here, the LX and X part right there. And then 9. How do I represent 9? Because I don't have anything for 9 here. If I put XI, then it would be 11 more. So I need to do IX. I need to subtract that smaller one from the bigger one to the right of it. So this I'm going to replace, or not replace, but write as IX. IX is the same thing as 9 in Roman numerals. So this and this match up here. And that's my whole string of numerals as 379. So you'll notice, again, a lot of these are longer to write than what we have in the Hindu-Arabic system. So still not, I think, the most advantageous system. I think we can come up with better systems still. So this one took a few there. 1994 took all that there. Why did I have a little picture off the side? Well, surprise! Each one of these little surprise slides, a lot of them have surprises. That is a person right there, if you can believe that. This, I believe this picture was taken in Redwoods National Park up in Northern California. If it wasn't, it was taken in Sequoia National Park or maybe Yosemite National Park. They have some really big trees there too. But the coastal redwoods, the tallest coastal redwood, the tallest tree in the world is in Northern California in Redwoods National Park. It's 379 feet tall. And then there's a giant sequoia, the tallest giant sequoia is 311. Both of these things are taller than the Statue of Liberty at 305 feet, and the United States Capitol building is taller than both of those things. Pretty crazy that there's a tree out there that big, a living organism that's that big. That's amazing. Alright, so let's talk about some multiplicative systems. Some systems that utilize more of the types of things we have in our place value system. So let's see what I mean by that. What in the world are you talking about, Mr. Wagner? Well, let's talk about a very specific system, the traditional Chinese system here. So we got some China, cultural Chinese things over here. Great Wall of China. Would really, really like to go visit that someday and visit China just overall. It seems like a really fascinating place, really wonderful country to go and visit. But let's see a couple things, or write down a couple things about the traditional Chinese system. So one thing that we need to know about this system is that numbers are always written vertically. Numbers always written vertically. So there's nobody that said, hey, you got to write numbers horizontally. Nobody ever told the ancient Chinese people that you were supposed to do it that way. Some cultures did it that way, and some cultures did it this way. They just kind of came up with their own way of numeration, their own system of numeration. So numbers are always written vertically. And one other thing we definitely want to write down here so we know how to do these problems later, that the number on top is from 1 to 9. So it's always going to be a number from 1 to 9. So from here to here, one of those 9 numbers, 1 to 9. And it's inclusive. It includes 1 and 9. It's not in between, but it's in a sense in between and including. You could say it like that. Inclusive and is multiplied by the power of 10 below it. So rather than me try to explain what I mean by that, let's just go to an example, and then the explanation I think will be a lot clearer. So, do I expect you to memorize these numerals? No. Only the Roman numeral ones do I expect you to have those memorized. But these numerals we're going to just look at either our books, or I'll give you kind of a cheat sheet, you might say, having the symbols on it so that you know what is what. So let's move on here to example 7. I think I wanted to put these in here, so let me see if I can just copy and paste that real quick. Copy and paste. Nice. Okay. So let's work through this example. So let's say we have 3,975. I give you that Hindu Arabic number, and I ask you to write that in Chinese, basically, in traditional Chinese numerals. What is this going to look like? Well, if we look at our table down here and remember what I said back here, numbers are always written vertically, and the number on top is from 1 to 9 inclusive, and it's multiplied by the power of 10 below it. So these are the powers of 10 here. We've got 10, it's 10 to the first, 100, it's 10 to the second, 1,000, 10 to the third. So we're going to be using these three things to kind of represent thousands or hundreds or tens place, and then these will be our single digits, and this represents this crazy looking thing. I don't know why they didn't come up with something easier to write than that for 0, but that's what they got. So 3,975. I'm going to rewrite the number down here, and when we're doing problems like this, I think this will be the easiest way for us to write these things or to think about these things. So 3,975, leave yourself a decent amount of space here. That would be the same as 3,000 plus, in a sense, that's this plus this. I'm not going to write a plus sign here, but it's this, plus, that would be plus 70 plus 5. So my thousands, my hundreds, my tens, and my units digits, this excuse me, is the same as this. And for those of you that missed writing your braces, oh, look at that brace. That is a beautiful brace. If you missed set theory, we're going to use the braces when we're doing Chinese stuff here a little bit more. So 3,000, this would be written as something like this. So you have a 3, looks like this. I'll do my best to make it look like what I see down there. And as long as you do your best and I can tell that it looks similar to that, we'll be okay here. We don't have to be professional Chinese numeral writers, but we do need to make sure it looks like it's supposed to, at least a little bit. And so we have this, and it looks like something like this for that. So this would be 3,000. Basically taking this times this. That's why it is a multiplicative system. We're taking things and kind of multiplying them together. So 3 times 1,000. 3 times 1,000 here. And so let's write that off to the side here. This is 3, and this is 1,000. 3 times 1,000 right here. This one, 900, this would be, what's 9? I want to write that first up here, and then what's 100? I want to write that next down here. So what is 9 represented by? Well, it's this looking shape right there. So I'm going to say that is, it's not too pretty there. Let me try that again. It's like that, and then something kind of like this. And is this going to be perfect? No, but hopefully you can tell that it's matching up here with the 9 right there. And then 100 is this kind of, I don't know what I'd call that, but maybe like a little lamp or something. So like this, you can see this a little clearer if you look in your book. So something like that with a little horizontal guy right there, and then this, and this kind of goes across like that. Okay, so this is 900. This is 9 times 100. 900 represented by that. What is 70? Well, that's 7 times 10. So that's going to match up here. This is a 3. This is 1,000. This is the 9. This is the 100. I'll write the 7 here, and I'll write the symbol for 10 right there. So what's this look like? Here's 7, so it looks like kind of a funky T to me. Funky lowercase t. And what is That's not the best, but I think you can tell that's supposed to match up with that right there. And then what's the 10? Well, that's kind of this cross-like symbol, offset a little bit. So something that looks similar to that. Look at the symbols and not what I'm drawing to see best what they're going to look like. So that, I would say, would be a pretty good representation of what I have down here, 7 and 10. So 7 times 10 gives you the 70, and then what gives you the 5? 5 is just represented by this right here. So we've got kind of looks like a chair almost with a little horizontal bar there. I've got here something like that, and bring that there. And so that to me looks like a pretty good representation of what I have down there. This is my 5 right here. So this is 5. So my final answer, and notice I wrote it vertically because that's how we're supposed to write the Chinese symbols. My final answer would be this right here. So I'll box that in. That would be how the traditional Chinese people would write 3,975, or how the ancient Chinese people would have written that number in their system. Okay, and I forgot to mention something about this last slide. Again, I keep forgetting to pull these pictures out. Well, this right here, well, the longest loaf of bread ever cooked, it used to be, in my old book, it used to be 3,975 feet long. That's why I went with this number here. I think this was a new record. They broke the record. I think it was in Italy. I'm not sure how long this one was, but that is one long loaf of bread. How they ever cooked that, I'm not sure. Did they get like blow dryers and blow on it? I don't know. There's no oven that big. How do they connect that together? I have no idea. Did they cook it out in the sun? Did they? I really don't know. I have no idea. Maybe I'll have to look that up. So let's do another Chinese numeral example. And we talked about zeros, or mentioned zeros a little bit. So here I'm going to show you how you deal with zeros in the traditional Chinese system. So I'm going to say this is part A to this. Let's say we had the number 8,060. In part B, let's say we had the number 8,006. How do we represent those two different things using the Chinese system? So I want to go back here. I think I already have my copy and paste ready. Let's see if I do. Yep. So I'm going to take this. I'm going to put that down here just for reference. And let's see how we would write both of these numbers here. So 8,060. So I'm going to do the same sort of thing as I did before. I'm going to write 8,060 here. I'm going to say this equals, and I'll use a big brace right here. Oh yeah, look at that. That is pretty looking. That is nice. Let's see what we got here. So 8,060. This time I'm going to skip the kind of intermediate steps and just do this all at once. So 8,000 represented by an 8 above the 1,000 symbol. That's 8,000. So I have something that looks sort of like this to start. So I have that. It looks like a little bit of a curl there at the end, and oh, let's see, it looks sort of like this. Again, these pictures are not perfect, but you're trying to draw the best you can what it looks like, the symbol looks like down here. So this one, we've also got that for 1,000, so I need to include that right here. Alright, that looks pretty good. So this is what is represented, or this equals, right here, this is 8 times 1,000. Or in other words, that represents 8,000. Now it gets crazy. Really, this is 0? Yes, it's 0. So we're going to try to draw that as best we can. So to represent this 0 in the hundreds place, look at your book a little closer. Look at your book to draw this and see the symbol a little better. I'm going to try to draw as best I can what I could see with my book. This is what 0 looks like in Chinese numerals. Okay, so oops, it's a little thick there, but I think that's okay. Alright, this comes out kind of like that. Alright, and use my eraser there a little bit. Erasing with, no. Erasing. Is it erasing? I think so. Yep, it erased. It erased a little bit. And let's do. We got that. We've got kind of these two almost eye-looking things, and then it almost looks like a nose to me. And then maybe some wrinkle lines on the face. So that and that, and kind of like this, a mouth here. Alright, so it almost looks like a face to me. This is supposed to represent 0. So this is 0 times 100, or in other words, 0. 0 times 100 there. And now I'm supposed to have 60. So 60 is this with the 10 after it. So 6 times 10. The multiplicative system, we have the number on the top times the number, the power of 10 underneath it. So this looks something like this. To me, this looks like the Vancouver 2010 symbol almost. That little guy that they had for the Olympics, right there. Vancouver, one of my favorite cities in the whole world. Vancouver, Canada, British Columbia, beautiful, beautiful place. This I also need to do. Sorry, I need to do my 10. So that goes above the symbol for 10. That should be a little bit longer on the right side than the left. And so this, remember, is 6 times 10 or 60. In other words, 6 times 10 or 60. And so this would be my final answer. So I'll box that in right here. I'm pretty happy with my Chinese symbols so far. So this, well, what about this last 0, Mr. Wagner? You didn't include that last 0. That's one of the nice things about the Chinese system. You don't have to include, if there's just a bunch of zeros at the end, as long as there's no other numbers after that, you don't have to include those zeros at the end. So this is 8,060, the way I drew this. Now let's see what the difference between that is and this over here for 8,006. 8,006 is going to look something like this. So we're going to start off with this, same symbols here. Okay, so 8, and the symbol for 1,000 again. So this is here 8 times 1,000, or 8,000 again. Alright, so how do I do 2 zeros? Do I gotta write this thing twice in a row? No, another nice thing about the Chinese system is that they said you only had to do that once. So let me see if I can cheat here. I don't know if that's going to work. Let me try it. I will try to copy and paste that. Copy and paste. If this doesn't work, so be it. Where'd it go? Nope. I'm going to have to write it again. Nuts. Oh well. So let's see. This becomes, alright, so I'm going to do my best with the 0 again. Thought I was going to get away with something slick there, but nope. I'm getting more practice with it though, so I'm getting better at it, I think. So this, so that, got our happy little face here. Alright, so there's representing the 0 again. So this would be not only 0 times 100 in this case, but also 0 times 10 as well. That's supposed to be a 0. Let me make that a little clearer there. That's a 0. There we go. And so if this was just 8,000, all you'd have to write would be this. You wouldn't even have to write this 0 here because there's no other digits of any significance, I guess you could say, under that. There's no other non-zeros. So as long as there were no other non-zeros, this would be your answer for 8,000. But it is 8,006, so we still need to have that in there. And then we have to have our 6. So this is our symbol for 6. This little symbol right there again. So this looks like this. Now it's just plain old 6. It's not 6 times 10 or 6 times anything this time. So this would be all we would need to finish this up. So this is right here. This is just the 6. So this would be it. So notice the only difference really here was everything was the same except for this is missing in that one. And that would be it. I'm going to box that in. That's my final way to write 8006. It's part B there. So this system is getting closer to the system that we use, the Hindu-Arabic system, in that it kind of has, almost in a sense, place values. This is the 8,000. This is like the thousands place value. This is, in this case, like the hundreds here. If I go back to this previous one, whoa, it's a different slide, really? Okay. And if I go back to this previous one, this is like the thousands place right here. This is like the hundreds place. This is like the tens place. This is like the units, or the units place, yeah. So I don't know why there's two slides there. I think I know what happened. I think I copied and pasted the whole slide or something like that. So you don't need to draw that twice. But we have one more type of system, ciphered systems, and this one uses the Ionic Greek system. There's actually a bunch of different systems there. Let me get my book just a second here and see what other ciphered systems there were. So there was this Ionic Greek system, but there was also a cipher type system for the Hebrews, the Coptics, the Hindus, the Brahmins, the Syrians, the Egyptian Hieratics, and the early Arabic systems. A lot of those systems were very similar to what you see here. They just had their own symbols to represent different numbers. So in a Greek, or in this Ionic Greek system, this ciphered system, we've got 1 through 9, and then we've got this base 10 you might say, and then every multiple of that base is also represented by its own symbol. So 10 through 90 represented by these symbols, and then 100 is kind of like the base here, and then each multiple of that represented by its own symbol here. The Greek alphabet only had 24 letters, so you might see this little note down here. These are taken from the Phoenician alphabet. Our alphabet, 26 letters of course, but the Greek alphabet only had 24, so they had to borrow 3 extra letters from a different alphabet, from a different culture there, to represent those final 3 that they needed to get all the way up to this 900. So let's see how this Ionic Greek system works, and let's do something like this. So I meant to copy and paste this a second. Let me do that here and put that in my next slide. So copy. I don't want to rewrite all that down. This is, again, not something you'll have to memorize, these ones, but we do want to know how to use these. I think that will be sufficient right there. Okay, so you've got, let's write this. So I'm going to use this symbol right here, psi. It's going to got 2 little curls like that. Almost looks like a pitchfork. So psi, and then mu. If you find mu on there, it's mu. It's right here, matching up with the 40. Psi matching up with the 700, and theta. Let's use that one. Psi, mu, and theta. Psi, mu, and theta. Here is theta right there, matching up with the 9. So what would this be in our system, in the Hindu-Arabic system? Well, this is 700. So let's write that down. 700. We'd have this plus the mu is a 40. Let me match these up again. So this isn't something you'll have to do later, but for right now in your notes, I would like you to do this. So 700 plus the mu represents a 40. So that goes with that. And then the theta, that's represented, or that represents the 9 right here. So I have this plus 9. If I put all that together, that will give me 749. So you see, an advantage to this ciphered type system is that it's easier to write letters quickly. However, with this system, you'll notice there's a lot of symbols that you got to memorize, and this is only for numbers kind of up to 900. If you went beyond that, there's other things you have to do. We're going to do one of those other things in the last example here. So 749 would be the same as psi, mu, theta in this Ionic Greek numeral system. So let's do one more example here, and then we'll talk about these in a second. But ancient Greece, you had Homer writing the Odyssey, very famous book. Perhaps you read that in your English class. Let's say we had to write this as an Ionic Greek numeral. So 1115, what would that look like? I want to copy and paste what I had before again. So let's make that smaller. There we go. And I'll put this off to the side over here. Okay, and so 1115. What's 1,000? If I look down here, well, I don't have 1,000. Man, what am I supposed to do? There's no number for 1,000. There is a little thing they used instead. So they used, we're going to make a note here. Let's make a quick note here. If you have, we've seen this prime symbol before in set theory. We had prime to say it's the complement or not a certain thing. Here in this context, prime, the little prime symbol is going to mean that we multiply that number times 1,000. Multiply that number times 1,000. So let's make that little note off to the side of this example. And so what can I do? Well, I can take 1 times 1,000. So I'm going to take alpha prime is what that's going to look like. That's not how I want to draw that. Okay, so let's see. My alpha looks kind of like this, alpha and then prime after that. So this right here, this one, I'm going to connect with the alpha prime. That's 1,000 right there. 100 is, if we look at our table closely here, we've got 100. That is this rho letter right there. So rho looks like kind of like a P, but with no, kind of like a lowercase p, but there's no little part there. So rho just looks like that. So alpha prime, rho, we have that. We have this next one. This is a 10. So what's representing 10? 10 is represented by iota. So here's what that looks like. So iota is kind of like an I with a curl and no dot. Excuse me, no dot above that right there. So this is iota. And then what is 5? 5 is epsilon. So we have something like this. And you may recognize some of these letters from other math classes. You'll see that pi even has a representation of 80. So for us, pi usually means 3.14, but in this context, we're doing Ionic Greek numerals. Pi is going to be the number 80 instead. So if I were to say what 1115 is in Ionic Greek numerals, that's what it would look like. Again, you can look at extra examples in your book. It kind of breaks it down even further than I've done with some of these examples here. It almost looks like apple to me with a missing P. But briefly to talk about this and why I brought this in here, this is the Appalachian Trail. This is a trail that I thru hiked back in 2005. It's about 2,175-ish miles, and it goes from northeastern Georgia here, Springer Mountain, all the way through 14 different states here on the eastern coast of the United States, up to Mount Katahdin here, or just Katahdin in Maine, north central Maine there. Incredible trail, beautiful trail. Back in 2005, I had the pleasure of coming across this young lady, and she hiked the Appalachian Trail the same year I did, in 2005, becoming Odissa. Her trail name, she was a classics major. She read a lot of these old Greek classics and other classic literature from ancient times, and she took on the trail name Odissa. And so she was quite a phenomenal hiker, and she decided that she was going to go for not only just the women's record, but the world record, the men's world record on the Appalachian Trail, to try to hike this 2,175-ish mile trail in less than 47 days. 47 days was the record, so she was going for 46, and she made it. This number, 1,115, just so that you know why I chose this number. This young lady, Jennifer Farr Davis is her name. She thru hiked the entire trail with her support crew, her husband being the main person in that support crew that would come in different road crossings and stuff along the way. 1,115. is the number, approximately the number of hours she hiked. So if you divide 1,115 and divide that by 24 hours in a day, you're going to get 46 with a remainder of 11. She thru-hiked the entire Appalachian Trail in 46 days and 11 hours. That is, if you do the math on that, 47 miles a day. Pretty insane. She did that 47 miles a day average for 46 plus days straight. She had a lot of days where she actually even hiked for 50 miles a day. She had a huge long string of 50-mile days, one after the other after the other. Very, very impressive, and she currently holds the world record. I hope it doesn't get broken for a while, but she currently holds the world record for this. Pretty cool that a woman, I don't know of any other world record where a woman has broken the men's world record in something like this, where it's an endurance feat or a feat of strength or something like that. So pretty incredible. A pretty incredible friend I have right there in Jennifer. So this was it. This was our last example. A lot of brief, short examples there in class. We will practice working on a lot of this stuff, and hopefully have some fun activities to go along with it too. But hopefully that was very helpful for you. A lot of this, I'm seeing a lot of this stuff for the first time too, kind of learn it myself as I'm getting ready to teach you. So pretty cool stuff here. Hopefully you learned some stuff about other cultures, found out some pretty crazy world records, and enjoyed the video just a little bit too. So I will see you guys in class very shortly.